Hey guys, so today we're continuing this new unit on volume. So today we're going to be focusing on cones. All right, so today we're going to be focusing on cones. So far, let's just kind of quickly summarize which ones we've gone through. We've gone through a rectangular prism or a cube, which is simply just length times width times height. We also talked about a cylinder. That was the next one on our list. We talked about a cylinder, which is pi r squared times its height. Then we moved on to talk about spheres. Right? This one's a little bit trickier. It's 4 over 3 times pi, and then your radius r to the third power. And then the most recent one that we talked about was a pyramid, right? So it was length times width times height, but then we just simply divide that by 3. A pyramid is a third of the size of that cube that it fits in. So today you're going to see that we're going to be focusing, of course, as I mentioned, we're going to be focusing on cones, right? And it's almost very similar to kind of that pyramid and the cylinder, right? If you notice, there's a divide by 3 at the bottom, and at the very top, pi r squared times height. That's also the formula for volume of a cylinder. So what does that mean, right? It's like what it's taking bits and pieces of both of those. So let's go through and explain it. So a cone, just heads up, definition of a cone and its formula for volume. A cone has to have that circular base, right? So again, if it's a square rectangular base, that would be a pyramid that we're looking at here. But again, here we have a cone. To find the volume of a cone, you'll have to find the area of the circular base and multiply that by the height of the cone, and then simply divide that by 3. So if you notice one more time here, the very top part here says pi r squared times your height. That's the formula for volume of a cylinder, right? So let me see if I can even break that down even further. If you just focus on this part here, pi r squared, that is the area of the circle. That would tell you how much space that circle there is taking up. As soon as you multiply it by h, by your height, you're stacking a bunch of circles on top of each other, and you're ultimately creating a cylinder, right? Once you multiply by h, it's like you're 3D printing another circle on top of another circle on top of another circle to create a cylinder. Well, I don't want a cylinder, right? What I want is a cone. So in order to fix that, we simply divide our answer by 3. Why by 3? If you take a look at this cone, right? The cone that lives inside of that cylinder is just a third of its size. So that's why we divide by 3. Very similar to the pyramid when we were dividing by 3, just taking a third of its size. So the relationship between a cylinder and a cone, 3 cones, if you take 3 cones, they will fill up 1 cylinder with the same size base and height, right? So again, if you grab 3 of these cones, if they all have the same base and height, you can fit 3 of those, squeeze them in there to create this cylinder. That's why we divide by 3 at the end. And again, you don't have to memorize these formulas, guys. You don't. You can always jump back and forth. So again, don't stress about that. I'm not going to expect you guys to memorize the formulas. So this example says find the volume of the cone. Use 3.14 for pi and round to the nearest tenth. So make sure you guys have a calculator out handy. So volume of a cone. Well, let me write that formula down. Volume of a cone is equal to pi r squared times our height. All of that simply divided by 3. Well, let's fill in everything that we know. Volume is equal to pi. I'm going to leave pi just the way it is for now. What is my r? What is that r? Remember, r is representing your radius, right? Radius is from the center of that circle, that circular base, to the outside. So they actually give it to us here. It's 2 inches, right? Be careful. Sometimes they'll give you the diameter. So in this case, r is going to be 2, and it's to the second power. Now, what is my height? Well, the height of the cylinder, or sorry, not the cylinder, excuse me, the cone here, from the very tippy top straight down to its base, that measures 8 units. So we're going to multiply that by 8. And then, of course, all of that, once we go through and work that out, we're simply going to divide that answer by 3. Well, if we follow a little bit of PEMDAS here, we're going to multiply our exponents, 2 to the second power. We're going to do that part first there. Well, 2 to the second power, that means 2 times 2, which is 4. I'm trying to show as much work as I can here, right? Bring everything else back down. I'm going to show you guys step by step. Eventually, you can pretty much kind of just glide through this by plugging it into your calculator. The next thing we're going to multiply here is 4 times 8. I always like to leave pi to kind of the very end here. So let me scoop back up to the top. Volume is equal to, I normally like to leave pi for the very end. 4 times 8 is 32. So pi times 32 all over 3. Well, I have 2 more things that I have to do here, and I'm actually going to do both of those at the same time. So right here, what I'm going to do is I'm going to take 3.14, right? I'm going to take pi. So on my calculator right now, I'm typing in 3.14 for pi, and I'm multiplying that by 32, right? That's not 0.32, that's times 32. I ended up with 100. Actually, go ahead and write it out. I'll actually go ahead and write it out. 100.48, and all of that, we're going to go ahead and divide that by 3. So my volume, when I divide that by 3, take out my calculator one more time, my volume is equal to 33.49, and it goes 3. So they want us to round. They want us to round this answer to the nearest. Let's see, what color have I not used? So I'll use black again. They want us to round to the nearest tenths. So tenths is 1 space after that decimal. So if I look at the 4 to the right of it, there's a 9. So my volume here for this cone is 33.5. We're going to round up, and this is going to be inches cubed. That is our final answer. This cone here, it can hold 33.5 inches cube of space, of liquid if you're trying to fill it up, like if it was a cup or something. That's how much space is inside. That's how much space is taking up. All right. So number 2, let's try that one more time. Volume, find the volume of the cone. Right, so volume of a cone. Make sure you have the right formula. That is a very popular mistake that happens. Volume for a cone, right? It's going to be pi radius to the second power times my height, all of that divided by 3. Well, let's go ahead and plug in what we know. Volume is equal to pi. Now, what's my r? What's my radius here? My radius is going to be not 12, not that 6 that we see sideways. It is going to be 6, but not for that reason. Take a look. From the center to one of the sides of that circular base. Okay, that whole thing is not 12, right? The entire thing all the way across was 12. So only from the center to one of the sides here, half of that would be 6. My radius for this cone is going to be 6 centimeters. So please be careful. One of those mistakes that I saw you guys on last week's quiz was some of you guys were using 12 your diameter instead of 6 for your radius. So this should be 6 in parentheses here to the second power. And now we're going to multiply that by our height. Well, our height here, right, this cone is on its side. Our height from the very tippity top to the base is 6 centimeters. So we're actually going to multiply by 6 again. And then all of that being divided by 3. Well, let's go through and multiply. I'm going to leave pi the way that it is. What I'm doing here is I'm doing 6 to the second power first. So 6 times 6 is 36 times 6 all over 3. Well, if I continue with this to the very top here, volume is equal to, I'm going to multiply now, I'm going to leave pi the way that it is, but this time I'm going to multiply 36 times 6. I just need my calculator. I don't know that off the top of my head. 36 times 6, and it's okay. We get 216 all over 3. All right, so this time what I'll do is I'll actually multiply by pi and then divide by 3. So let's see what we get for volume here. So I take pi, which is 3.14, and I multiply that times 216. I'm doing that on my calculator just now. I got 678.24. I'm immediately going to say divide by 3, and I get a volume of 226.08. All right, so they do want us to round our answer again to the nearest tenths. So my volume here should be, this is the tenths place, 1 spot after the decimal. If I look at the right, that's an 8. We're going to round up. That should be 226.1 cubic centimeters, or centimeters to the third power. Okay, that's how much space that cone is taking up. All right, example number 3. Example number 3 says, how much more water in cubic inches does the bigger cone hold? So, right, looks like this one is obviously the bigger one, right? It's drawn bigger, the height is even bigger, and then the radius is even bigger. So we know that that one's bigger for sure, right? Bigger radius, bigger height. It's going to have bigger volume. So how much more water uh, does the bigger cone hold? Well, we have to find both of their volumes, right? We're going to take both of their volumes, and then we're going to take the big one minus the small one to figure out how much more water does it actually hold. So here you will see me kind of skip a couple of steps. So let's start off with the small one here. Okay. I'll write volume for this one is equal to pi r squared times, whoops, my height all over 3 divided by 3. So let me fill in what I know. I'm actually just going to go ahead and erase a couple of things and fill it in. So for example here, r, my radius is going to be from the center to the outside. Whoops, let me find a different color, not green, it's kind of blending in there. But my radius, right, my radius here, that was r, from the center of that circle to the outside is 15. So I'm going to go ahead and plug in 15 there. And then what is my height? I'm also going to go ahead and plug that in. From the tippy top down to the bottom, that measures 36 inches. So we're going to go ahead and put, whoops, 36. Now what I'm going to do here is I'm going to multiply a couple of things on my calculator and give the final answer for the volume of this smaller cone. So what is this going to give us when we work it out? I end up with the volume is equal to, now let me go through and I'll verbally kind of explain what I'm doing on my calculator. First, I'm doing 15 squared, so 15 times 15. That gives me 225. Then I multiply that by the 36. That gives me 8,100. Then I multiply it by pi times 3.14. I get 25,434, and then I divide that by 3. And I get a volume of 8,478 cubic inches. So again, that is just the volume of this smaller cone. That is just the volume of the smaller cone. That is not your final answer. That's not your final answer. I'm going to go ahead and box it in, but that is not the final answer I'm looking for. It says, how much more water does the bigger cone hold? So let's go ahead and find the volume of the bigger cone. So let's do the same thing here. We're going to put volume is equal to, the formula says pi r squared. Whoops, let me write that one more time with a little bit more space. Pi r squared times height. All of that divided by 3. Well, let's plug in what we know. Let's fill in what we know. Let me find a color that actually pops out. I'm going to go ahead and use purple. Hopefully it pops out. Radius. So what is my r here? What's my r going to be? The radius for the bigger one from the center to the outside. That measures 25. So we're going to say 25 to the second power. And then what is my height? Well, my height for this one, from the very top to the center, that measures 60 inches. So we're going to multiply here by 60. And I'm going to do the same thing. I'm just going to verbally explain what I'm multiplying, what I'm going through and I'm doing. So what does this give me? Volume is equal to, so on my calculator, I'm doing 25 to the second power first. So 25 times 25. I got 625. Then I multiply it by the height, which is 60. I get 37,500. When I multiply that by pi times 3.14, I end up with 117,750, and then I divide that by 3 at the end, and I end up with a total volume of 39,250 cubic inches. So again, that is not the final answer. That's the volume of the bigger cone. So how much more does the bigger cone hold? Well, this is just a subtraction problem, right? All we're really going to do here is we're going to go ahead and take the bigger one minus the smaller one, and that should tell us our answer, right? So the bigger one here was 39,250 minus the smaller one, which was 8,478. And if we subtract those, that should tell us how much more does the bigger one hold. So 39,250 minus the volume of the smaller one, 8,478. And I get a total of, I'll write a sentence here. It holds, or I'll write the sentence, the bigger cone holds 30,772 cubic inches more, right? More water. That is our final answer here. That's the one we want to circle. That's the one that we want to box in. So it's not just the individual volumes. You're going to have to take those individual volumes and then go ahead and subtract them to figure out how much more water it holds. Okay. Example number 4. It says the volume of this cone is 12.56 cubic meters. What is the height of this cone? Use pi equivalent to 3.14 and round your answer to the nearest tenths. So again, what we're doing here is our job is to find this height. They don't give it to us, right? That is our job. We're going to approximate. It's not going to be perfect, right? We're going to be using 3.14. It's not going to be exact, but it's going to be very, very, very close. So if you're trying to find the height, well, you're still going to use the formula. You're still going to use the volume for a cone. Volume is equal to pi r squared times height, all of that divided by 3. Okay, well, let's fill in what we know. Let's go ahead and fill in what we know. My volume here, I actually know my volume. They give it to us at the very beginning. The volume of this cone is 12.56 cubic meters. So we're going to put 12.56 for volume, and then we just set it equal to, bring down our pi. We actually know our radius. Our radius is over here from the center to the side of this cone. That measures 2 meters. So I can actually even plug that into to the second power times h. I don't know what h is. That's what we're trying to find. So it's okay if we leave it as h. That is my unknown. That's like my x that I'm trying to solve for. And of course, all of this is being divided by 3. Okay. So there's a couple of ways you can kind of continue this problem. First things first is I would prefer to get rid of the fraction. I would prefer getting rid of that dividing by 3 first, right? I prefer to do that. So the way we get rid of dividing by 3, what's the inverse of dividing by 3? It's to multiply. So what we're going to have to do here is we're going to have to multiply both sides times 3. All right, so let me do that for the left side. What is 3? Let's see, 3 times 12.56. That gives me 37.68 is equal to pi times my radius, which was 2 squared, times my height. And these 3's end up canceling out, so I don't have to bring them down anymore. Well, what can I do next? We can simplify that 2 to the second power. So we're going to bring down 37.68 is equal to pi times 4, right? 2 to the second power is 4 times h. Well, at this point, there's a couple of things, again, that you can do. It's up to you how you want to continue this. What I would prefer to do here is I would multiply pi times 4, or 3.1 4 times 4. Let's see what we get here. What is 3.14 times 4? What's pi times 4? So I'll end up with 37.68 is equal to 12.56h. Well, I have one more thing that I have to do. I'm actually going to scoot this back to the very top. I have 37.68 is equal to 12.56 times h. Well, the way that we get rid of that 12 is simply going to be to divide. We're going to divide by 12.56, divide by 12.56. So what is 37.68 divided by 12.56? We get a total of 3. 3 is equal to, those 12.56 cancel out. That is equal to h. So our height here, our height is 3, and it's 3 what? We're using m, so it's 3 meters. Make sure that you have the right units, right? Not inches, not centimeters. We're talking about meters. So our height of this cone is 3 meters.